So as Joel mentioned, we're very interested in root cause analysis, fault isolation, but not necessarily in the heavy-handed automation sense. So starting to tackle that problem, obviously one of the key issues that you need to be able to solve at 3 a.m. when your phone rings is it the application or is there a network problem? And being able to make that binary decision so you can make sure that the call gets routed to the right person or somebody needs to get out of bed and help solve that problem. So the way we're tackling this in NPM 11 and 11.5 is with DPI. So we're now capturing packet level data through a couple different methods. So either sensors that are deployed on endpoints, so servers in your enterprise, or attached to a span or tab. So dedicated stream coming off a network device. Using that data, we're then able to generate network response time and application response time. So time to first byte and TCP three-way handshake. Being able to isolate, is it a network response time or is there something on the server application side that's causing some sort of latency? Being able to make that binary decision and reducing, not MTTR, but mean time to innocence. So you can make sure it's somebody else's problem and they get the call in the middle of the night. So also bringing together all this data that we mentioned on the back end, I'll go through some examples as to how our quality of experience dashboard surfaces that information and ties everything together. So let's take an example in the case of, let's say, FTP here. So certainly this is contrived. I already have FTP up. So here we can see FTP has a higher than usual network response time. So also with NPM 11, we support dynamic baselines and thresholds. So we can determine what's normal in your environment. So is this a abnormal event based on a 7-day sliding window? And if it is, well, let's alert on it. So here we can see that FTP network response time took a spike. Looks like a few hours ago. So let's drill in and try to find out why that may be. So we'll go to the application details, which will again confirm what we already know. Network response time is quite high, and what nodes are involved in this transaction. So we'll go over to the server that's serving my FTP application. So here we have a whole host of information. One of the key things we should be concerned with is response time and packet loss. That seems like a big red flag that something is amiss. Not really so much concerned about memory CPU. That's pretty middling at this point. Also pulling together our various data sources, so topology information. So here I can see that this particular server connects to this interface on this device. So let's walk back that topology path and see what's going on. So again, contrived. We have an end device connected to a router, but for the sake of brevity. So here we have statistics on the router. Here we can see that we had some route flapping happen historically, and big red flag, route change about 17 hours ago. So perhaps now we're not going out an optimal path, and now we're experiencing some packet loss and/or latency response time. So end-to-end, bring it together from the initial binary decision point. Is it the application? Is it the network? It's the network. Let's walk down that path and try to find out where that fault may lie.
Now that says default route changes. Can you check other arbitrary prefixes?
Yeah, so we actually capture route tables. So it's
you're capturing the whole route table.
Yeah,
okay.
Yeah, absolutely.
This is actually quite good in that. Yeah. Like I work with a bunch of different network monitoring tools, and for most of them, they either don't track routing changes, or you need an add-on with the product name escapes. There's separate guys that do some really cool route analysis. But yeah, the other network monitoring tools, they don't really include this, and yet it's a pretty obvious kind of a thing to have and want, right? So
and obviously you can alert proactively and that sort of thing. So definitely good to be woken ahead of time before you find an application issue that it was actually related to a route change.
You were saying that this initially, when you started going down this rabbit hole, it was. You were talking about a sensor being deployed on a server. Can you talk a little more about that? So is the view that we're getting the server-side view? It's not really an end-user view, right? It's a server-side view.
Correct. It's a server-side view of the transaction. So we're either capturing the data on the server itself or via a dedicated sensor that's somewhere in the data path. So maybe it's a span off a core switch that the upstream server is then connected to. So we're capturing that data as we see it.
So we have to know where the complaints are coming from first before we're able to.
So it could be related to a remote site, or it could be related to the server itself if there's a specific server that's having an issue. whatever the case may be.
I just bring it up because, well, I mean, we saw NetBees, and theirs was from the end user perspective and being able to track an application. And so it seems like this is the flip side of that. You're on the application side tracking back.
So that's correct. And we're definitely interested in the inverse, which is being able to track individual endpoints. So we already have NetFlow, which gets us conversation volume, that sort of thing. But in terms of the response time for the endpoints, that's definitely something we're interested in.
Okay.
Yeah, so what I think I'm hearing is with the tap or the position in the middle, be it on the server platform or whatever, you're getting sort of a binary split of is it this side or is it this side, which is a good thing for telling you you have a problem and giving you a rough idea of in which place should you look, server or network, MTTI. What do you have that helps with the next step? Like if it's the network, what I might have, and thanks to Bob for his term brownout, I might have a brownout where the network is just gone, there's lousy performance someplace between the user and the probe. Now, how do I figure out which hop along the network that is? Because what I'd like to do is identify the traceroute hops and then quickly check the stats for packet loss and so on each of them.
Yeah, so the hop by hop and effective bandwidth and packet loss per hop, definitely a known issue and definitely something we've been talking about, but not something that's currently a possibility with our DPI program.
Well, and it's not a possibility with most tools. It's just the light bulb went on that, gee, I'm seeing people writing down a trace route and then they're clicking through whatever their tool is and pulling up stats, and it takes days to do it.
Yeah, and we'll go a little bit more in detail once he's done with what we have right now in the product of where we're trying to go, and that definitely fits, right there. And that's, we'll talk about this in a few minutes.
You make a good straight man.
When you pulled up that shot of the route change that was added, you were able to first tell us that, well, the application was connected on this port to this device, and then you went into that device, which was the router.
Yep.
From there, now can you go follow the path?
Provided we have topology information. So we support CDP, LLDP, we pull bridge mid information. So we have a litany of topology information. And we'll go into some of the other fun stuff that we can do with that when we talk about automated dependencies. And we'll discuss that when we talk about 11.5. So the inverse of that conversation, so let's say it's an application issue. So in this case, I can see that our dynamic thresholds have said, my SQL response time is quite high, and it's been quite high for some time. So let's drill into that. And we can confirm the existing information and say, all right, what server's involved in this transaction that may be a bit abnormal? Hovering over, I can see that the application health on this is not good. So CPU, that's a bit high. Memory, it's a SQL box. It's supposed to be pinned. What's really interesting here? Well, again, bringing together all the information from our portfolio. Here we have information coming in from our server and application monitor product, SAM. We'll use too many acronyms. And here we can see that this particular database instance may be having some issues. And we won't go as deep into the SAM side, owing to the audience, unless you guys want to. But from this App Insight for SQL, I can see that this particular SQL server, red is bad, green is good, catering really to the accidental DBA, the guy that may get the call in the middle of the night that may not be a SQL expert and needs a bit of guidance to help him solve this problem. But just to give you an idea of the level of detail that we can go into here, and we can even pull top 10 expensive queries, long-running queries, who's running those jobs. So again, our accidental DBA may not be an expert, but at least in the middle of the night, he can go kill whatever job he needs to, or go tap somebody on the shoulder and let them know that they shouldn't be doing a select star. Any questions on that path? Any questions regarding ART, NRT, how we're capturing data? All right.
I have an NCM question, but if you're going to get more into NCM, I'll hold it.
Yeah, we can talk about NCM, sure.
Okay. So I've used the product before. It works really well for simple changes. Obviously, you can do a lot of advanced scripting with it. But one of my questions is, in the last 12 to 24 months, we've really started to see some uptake in API access to networking devices, both for extracting configuration data as well as pushing configuration data. And generally, that's a much more positive interaction with the device, then expect scripts and screen scrapes and stuff like that.
Sure.
Are you guys looking at integrating that kind of functionality? Because the thing is, everybody's right now, APIs are hot, right? API. But if I'm not writing my own tools, that API doesn't help me a whole lot. What I'd like to see would be commercial tools that just use a more positive mechanism to make, retrieve or configuration or make change. So I'm wondering if you guys are looking at that as a direction for enhancements to NCM, as now that we're really getting to a point where a good number of vendors are supporting, at least in some portion of their product line, API access to devices.
Yeah, we're always looking for opportunities to streamline the product or provide a better end user experience. Mm-hmm. And when we reach the tipping point where, let's say, Powell, for example, that's going to be the primary mechanism that we can interact with the device or provide more functionality or easier configuration for the end user. Mm-hmm. That would be the point that we would go implement such a thing. I mean,
so you're not there yet, but it's
yeah. I mean,
on
if
your
you're
radar,
familiar with NCM, there's a lot of vendor or device specific configuration that needs to occur there anyway. So in terms of an abstract API on a per vendor basis, at the point it makes sense for us to do that from an efficiency perspective and an end user perspective, we definitely do that.
Okay, thanks.
So you'd like to have tail F light?
I didn't say it that way.
I did.
All right. So from there we can segue into some of what's new with NPM 11.5. I already mentioned automated dependencies. Let me pull that up just a moment. So automated dependency mappings is brand new in NPM 11.5. Basically using our existing topology information, we are able to stitch together essentially graphs in disparate sites. So let's say I have a remote site that maybe I don't manage the end equipment. Maybe it's MPLS or some CP involved that I don't manage. So in order for us to be able to determine what may be the bridgehead device in that remote site, we actually use a combination of our existing L2, L3 topology information, and the new NPM 11.5 is traceroute. So tracing path back from the main polar or additional polars to those remote sites to determine what those dependencies are. So the practical effect of that is better alerting. So let's say I lose a border router at a remote site. Instead of getting a flood of 10 different alerts, I would just get one. Now, certainly you could do that today using a combination of groups and dependencies in a manual fashion, but we have that now automated in NPM 11.5. So that's a good feature.
So I've worked a bit with some other tools that promise a lot in that regard, and it turns out to be kind of hard. It's hard to do it well and reliably. It's a really good idea. The concept is fantastic. But yeah, I've seen sites where maybe the topology gets a bit confused about what's actually going on, and then it goes, oh, I don't need to alert about that because this other one's down. But so it's cool, But it turns out that was because you decommissioned it and there's some new path, but it hadn't all been discovered properly. And it's a challenge.
Yep, the dependencies are only as good as our topology information, which is why we did introduce traceroute just as kind of a authoritative L3 path. So that's the rationale there.
Yeah, the ones I see are like, say, if you haven't discovered all the devices through the network, then your topology information can get really confused, and then some of that automated alert suppression and stuff it just can't handle it.
Yep, and in the event that we do calculate something incorrectly, you can certainly ignore the dependencies or choose manual groupings, whatever the case may be.
Yeah, I've seen you can do like an override feature as well, So you might suppress stuff and say, well, okay, that site's got this one edge device, and if that's down, well, effectively everything else is down. But sometimes you want to say, well, that's cool for those 20 access switches, but you should probably still send me an alert for those other core devices at that site. It's kind of like a fallback, so you might get 2 or 3 alerts rather than 20 alerts. So, yeah.
Yeah. Also in NPM 11.5, we did redo our alerting engine. There is some ability to condense some of that alerting, not just based on alert suppression or dependencies, but just the number of devices that may have a similar condition occur at the same time. Again, just intelligent alerting, making sure you don't blow up your phone and make it useless in the middle of a firefight, but be able to actually effectively troubleshoot the issue. Another very interesting feature that we introduced is capacity planning. Oft requested and perhaps seen in a lot of multi-million-dollar solutions, but we're making it available in NPM. The ability to proactively alert on exhaustion of various constraints. So CPU, memory, interface, storage. If you've ever pinned a WAN circuit and then had to make a panic call to a provider to get that stepwise bump up to the next tier, and then explain to your boss the budgetary constraints and getting raked over the coals by the provider, you can avoid that circumstance and be alerted, 2 months out, let's say, that exhaustion is going to occur. So we have 2 different methods of calculating that based on either peak value, so for critical resources, let's say a WAN interface, or average for let's say volumes that may have spikes during backups, but you're just really concerned about the average over time. So that's a linear regression algorithm over a 7-day sliding window. So we're able to calculate by default 60 days out, proactively alert on that. You can report on it, and you'll see those metrics rolled up in a variety of dashboards and on node details as well. Any questions on that?
When you talk about interface capacity planning, you talk about utilization or port counts, or
so talking about utilization on the interfaces themselves, our UDT product actually has port density. Right on top, you have a pie chart that says, here's my percentage used, here's my percentage available, and that's readily available in UDT.
Okay. Yes, that's covering average number of ports used during business hours, kind of a thing, that sort of stuff.
So if you
because you know how it is, if I average it over the week, maybe I don't get quite so accurate numbers.
Yeah, business hours reporting on Activereports. I'm sure with some SQL magic we could tease that out, but that's not an out-of-the-box report that we have.
But I mean, the sort of thing I'm getting at, though, in terms of you're trying to figure out how many of my access ports are in use, typically, how many am I looking to need, but yeah, and just trying to map that through to taking into account the fact that people come and go,
Yeah, and we definitely have the data. The only wrinkle would be, the business hours factor, and then also your polling frequency, how often you'd be polling that information. Let's say it's a college campus and you have, ports going hot every 10 minutes or whatever the case may be.
In that capacity planning, can you look at things like PoE load or even power capacity and UPSs that you're monitoring?
So currently we have CPU, memory, interface, storage. Now, as Joel mentioned, we have a core platform that we take advantage of. So as other modules would like to be able to calculate values for capacity, I imagine we'd see more of that as that progresses. So another great new feature that we introduced in 11.5 is wireless heat maps. So some of you may be familiar with wireless heat maps from some other
You're
vendors.
making the PC in the room feel happy.
What's that?
Less alone, at least.
Does not like that my resolution here, but let's go through a sample wireless heat map along with what we call a virtual site survey. So to give context, some of you have used proprietary vendor tools to either look at current radio energy saturation or try to do planning, that sort of thing. Hopefully that, oh boy, hopefully that gives you context.
Demo effect.
Hopefully the alert roll-up feature is covering any disconnect there.
All right, let's go to the backup. Bear with me just a second. For those of you that have used NPM and Network Atlas, the Network Atlas interface should be familiar to you. when it comes up. And we'll flip back to that in just a second. So it looks like our venue maybe could benefit from some wireless heat map as well.
Yes.
All right. So let's look at the output of wireless heat map just for brevity. So I'll leave it to your imagination, at least until my VPN connection reconstitutes itself, as to what that looks like. But this would be the output. So the ability to lay down a floor plan, overlay APs that are managed by Cisco Wireless LAN Controller. Over the floor plan, we are then able to calculate signal strength and overlay client location. So if let's say you have a hospital with Wi-Fi enabled carts and somebody wheeled something into a closet, where is that device currently? Or maybe in a BYOD setting, you have a unmanaged device that's consuming a great deal of bandwidth. You don't really know who Jim's iPhone is, but you do need to go tap Jim on the shoulder. You can find that person physically, tap them on the shoulder, and ask them to discontinue their.
That's pretty cool. Can you show how many clients are associated with an AP? It seems to be a growing problem.
Down at the bottom there. Is
Yep. So that is existing functionality, and you can report on that as well. So if you're looking for like maximal client count or that sort of thing.
Yeah, because the configured maximum is the problem with the older Cisco APs. The multiple devices per person, particularly in hospitals, are kicking it over 40 or whatever.
So obviously you get you make the first guess once everything gets placed on the map. Mm-hmm. Do you look at, when you start looking at clients, you can actually I'm assuming you're doing geolocation, something along those lines, because it sounds like you're saying you can see them on the map and you've got an idea of where they're at.
Yes.
Right?
So if my VPN were to cooperate with us, I could show you exactly how that works.
All right. Well, I'll take it a step further, and then you'll probably answer my question, but I want to get it out there to make certain it gets answered. So do you then begin using client location to fine-tune your heat map based on what you're seeing there?
That's a wonderful segue to what I'm about to show. So,
wait a second, all right?
Like I said, I want to get it out there. You can answer it whenever. I just want to make sure.
And I asked my question poorly because I'd like to see the numbers on the APs, because then I can see where I have traffic density on my map. That was maybe the
on the hovers themselves, and then also ingress egress by client. I can tell you that's actually not there right now, but something that we're definitely interested in. Cool. So why this loads, to answer your question, first step in the wireless heat map creation process is to obviously upload your background. After that, we set scale. So rather than have to model, let's say drywall or glass or elevator shafts, that's terrifying. Why would you ever want to do that? So rather than have to do that, you just set scale and tell us how long this wall is. And after that, we are able to base our calculations. You then drag your APs onto the map itself. From there, you can just click generate, and then based on how the other APs see the other APs, right, we'll be able to provide a pretty good guess as to what that looks like.
Sure.
More or less. After that, we have what we call our virtual site survey, which is if you have a known location of clients at a given moment. Let's say Steve's at his desk right now, and Mary's the receptionist, and she's there from 9 to 5. You can drop their locations onto the map of the connected clients, and from there we start to build a fingerprint. Think of it that way. So it's a point-in-time location of a particular client, and how all the various APs see that client, right, and the relative signal strength. So we use that over time. So let's create a new wireless heat map.
Okay, so you are really using the clients to help really tune and tweak your heat map so that you actually start to see a little bit better. I mean, obviously, walls are a good example. If you look at the heat map that you have there, you're going to have more dB loss than what you're really showing. Especially on that initial, when you first load that map up. Mm-hmm. But if you can start using, essentially, you're using your clients as remote sensors. That's when it becomes powerful.
Yeah, anyone can draw So what we do is significantly more advanced. And we talk about like a remote site survey. So let's say you have a remote site you inherited, and somebody's complaining about wireless coverage, whatever the case may be. You don't want to have to fly out there, say, hey, can you go sit in the break room? Hey, can you go sit behind the elevator, and go from there.
Okay.
Maybe you ping them on IM or whatever the case may be. So at least within a few interactions with end users, you could be able to get a pretty good idea of what the wireless coverage looks like outside of what the APs see. So there may be some eccentricities with let's say construction material. All right. So let's set a background image. So here we have our sample background. Let me find our wireless LAN controller. And just bear with me because our backup environment happens to be in Eastern Europe. So I will drag the APs onto the map. Now, this implies that I already happen to know where these are in physical space. So that may be from as-built plans, or I just happen to know them. But I'm a diligent administrator. I should happen to know where those happen to be. I can set scale. So I happen to know these cubicles are in blocks of latency. There we are. And these are, let's say, 10 feet or meters for the metric folk. And we'll go through and we'll generate the map.
So at this point, it's going to be best guess, right? Without any clients that are on there, it's a rough approximation.
Rough is a rough term. So it depends on how many data points we have, right? Based on how many APs can see how many other APs and their relative signature strength to each other and where they are in physical space.
Okay, I'm just so I'm throwing out a scenario here. Like, okay, so bad AP placement. You have them all down a hallway, and all the APs can see each other beautifully. Right, and you're talking like a hotel build out, right? Then you get out into the rooms, you get to the edges, everything dies off. You're not going to see that from this. This is the rough approximation.
Well, that's you need the endpoint, visibility.
Because when APs are all at the ceiling, they're all a similar height. They're all, there's no cube walls. There's none of that stuff between them. So what they see versus what a client sees.
There's nothing wrong with that, especially when you're saying that you're refining it with data as you go along. Right. I was just trying to understand where we're at in the process.
Yeah, you're limited with what the APs are telling you, basically. At the point.
Right, perfect. Thank you.
And just to give you an idea of accuracy, so in beta testing, we've actually seen an accuracy to about 3 meters, 10 feet or so, in terms of client location. So the more data we have, and the more data points we have, the more we're able to refine that. So if you have a campus environment, let's say, with a lot of outdoor areas, if you can give us more specific data at each of those outdoor points, we'll be able to provide you a pretty good picture of
what type of characterization do you do of the client? Because if I'm sitting there with a MacBook and I've got three decent antennas versus some type of handheld that has a single 0 dB antenna, those two things are going to see completely different signal levels.
Correct.
Right? So do you do any type of client classification and calculate that in?
So we're not interrogating the endpoints, obviously,
right?
But rather it's the values that we're seeing on the APs themselves.
Okay.
So we should be as accurate as the data that the AP has.
Okay.
Which depending on the sensitivity of the device, but it is relatively good. All right. So fail on the backup.
What vendors would be supported with?
So currently Cisco only. So modern-ish generations. So 5500, 2500, et cetera, et cetera. Anything that supports clean air MIB. Obviously, we'd like to expand that in the future to other vendors. And in traditional SolarWinds fashion, we tend to work through customer demand and then market penetration of vendors. All right. Any further questions on wireless heat maps? All right. Another very interesting feature.
Actually, I do have a question about the wireless heat maps. Are you able to use that for any sort of predictive analysis? Like, can you more or less, hide or remove an access point to see? Does it do any modeling of what would happen, or is that purely real time, like what it's actually seeing?
It's purely real time. So in terms of what if or planning for build out, that sort of thing, that's definitely something we're interested in, because that's kind of the second half of that equation, but not at the moment.
Okay.
I just want to understand one thing. So, in relation, if this is only supported for Cisco APs, are you focused on customers that are already using SolarWinds that maybe don't have Prime, or is there some differentiator between this and Prime? I'm just not sure about that.
So we find that we have a lot of customers that use Prime exclusively for wireless management. And we would very much like to be able to bridge that gap, and as Joel mentioned, give everyone the single pane of glass.
I see. Well, that's a good answer.
Yeah, that was kind of my question is, what is gained by reinventing a wheel that is highly likely to occur in Cisco environments?
It's really seeing everything into the same interface, and not having to jump into the other one. If we can do it, I think that there's a set of tools that will not replicate, for sure. There's not enough demand, or it's too specialized, but this was falling into the category where enough people were asking for this that, it made sense for us to actually have this into our own UI. Just like, we added the UDT stuff also. You could have said, Cisco Works at the time was providing, who's using that port and all that stuff. We bridged that gap, and now, 2 years later, we have another, kind of use case that we can add. We're not necessarily trying to displace them, but if we can find out features that basically are very useful for the majority of our users and bring that.
I think in your customer base, I keep thinking in terms of fiddle factor, how much time you have to invest in keep maintaining the tool. And if people are used to working with your tool because it crosses a lot of products, then Prime may be viewed by them as a pain. And they may choose to put the energy into your product because it gives them what they need, and maybe Prime is just more maintenance intense.
I would say most Prime users view Prime as a pain.
Yeah, well, there's kind of that disconnect there, but I've heard a lot of harsh words about Prime lately.
And we would definitely,
as a user.
Yeah.
I think they're getting there. I think based on where they're trying to go, but.
So good point that, you kind of got to use it to some degree.
And to the point before about bringing together all the various data sets that we have, why would we want to do this? Well, let's take mobile device management in a BYOD sense. So the example I gave before, where somebody has a authorized device in whatever sense that is on the network that's doing something that we would not like, and being able to find out who that is. Well, with our UDT product, our user device tracker, as Joel mentioned, we have Active Directory integration. So parsing Active Directory security logs, we know who's logged into essentially what device, and then what they may be connected to. So being able to tie that all together, may be very handy in a BYOD sense.
Actually, a question just came in on Twitter. Are you guys able to use RFIDs as well for location?
So active RFIDs?
Yep.
So what we might consider to be Wi-Fi enabled RFIDs? Yes. So not the passive sort. There's a lot of really cool stuff you could do with internal geolocation, especially with like high fidelity APs and that sort of thing. Not the focus of what we're doing here at the moment, but we may. So you can imagine that there's some other problems you can solve based on client location, such as maybe I'm concerned about device egress. So something leaves the building, I want to be able to alert on that. Maybe there's something, there's a device in an area of the building that it's restricted. I want to be able to alert on that as well. So those are thoughts we're having, but nothing at the moment.
Okay.
And one other question, does this talk directly to the controllers?
It talks to the controllers, yes.
Okay.
Yep.
It is direct.
So thin APs. Another very interesting feature in 11.5, and I think I heard it mentioned in the NetBees talk, was automatic geolocation. So now based on S&P location, we are populating the relative device location on the map. So that overlays with status information, group information, et cetera, et cetera. some very interesting applications there. Imagine you have a cruise line with some devices that are returning location information, and you want to be able to plot those on a map along with status. So that is now a capability we have today. Any questions on that?
What exactly are people putting in that field? I'd have to say that I've seen it more ignored than used.
So there certainly is that issue, and would you believe I think there's a place called Unknown in East Africa?
North Pole Santa Claus?
Yeah. So that certainly is an issue. We also have the ability to read in data from custom properties, if you're familiar with how we use custom properties, essentially arbitrary fields. So we can read that in, or read in custom property fields for latitude, longitude, and place that. So if you're not using SNP location, then there's an option there. In the spirit of what we mentioned before about out of the box, we want to provide maximal value. Let's try to make that as easy for folks as possible. So.
Well, I was thinking of, this sort of came up with the NetBees guys, but what occurred to me is a sort of Meraki-like approach where you read a code or a barcode or something on the device, and then you use the GPS on the phone to feed the app, and then maybe set the location in the device to make it easier. So invert it.
Gotcha. So for, let's say, the dynamic nature, if you're familiar with our
tend not to move.
Yeah. If you're used to our universal device puller, so we can pull in arbitrary fields and put that in custom property and go from there.